We are the Pediatric Test Mannequin Senior Design Team made up of various engineering disciplines. Children with muscular dystrophy and other lower limb disabilities often use pediatric standards for physical therapy. All standards currently on the market are not motorized and require someone to manually push the stander, taking the child's sense of independence away. The pediatric stander has been an ongoing MSD project for several years now. Previous teams have designed and developed separate systems of a motorized kit, pediatric mannequin, and a data collection system, which we have worked to integrate together this semester.
Our idea of success consists of a fully integrated and analyzed mannequin and sensor system, collection of meaningful safety data to present information regarding motor kit functionality and user experience. As per customer requirement, our design will be robust and reliable.
Our approach was unique as previous teams have worked on this project in the past. To start, we analyzed the current system and we brainstormed integration solutions. However, during feasibility analysis, we realized that it would not be possible to integrate the old system into the final solution. Thus, we designed and implemented a new sensor system, and we provided a data analysis system that connects via Wi-Fi to the data collection system. Finally, we ensured functionality and accuracy of the mannequin.
We stabilized the originally loose design of the mannequin's neck by reinforcing it with 4 steel cables. These artificial muscles are mounted from the mannequin's head to 3D printed detachable hooks clipped onto the spinal pipe and are adjustable using turnbuckles. Spacers were used to make sure there was enough vertical space for assembly.
To record the forces that interact with the mannequin, we use absolute orientation sensors, abrasion sensors, and load cell sensors connected to multiple Raspberry Pi Pico W boards that wirelessly transmits data to a laptop in real time, which will then populate a custom-made user interface. Housings for the orientation sensors and Raspberry Pis are attached to the inside of the mannequin using Velcro. The housings feature a built-in wire management system that prevents the wires from being disconnected from the sensor.
We would also like to thank our customers, Dr. Day and Dr. Phillips, our MSD guide, Harold, along with Nick and all previous MSD teams that have worked on this project.